Day numero siete. We're back. Got my coffee here, but it's rather full, so I'm not gonna bring it up to the camera. You're just gonna have to trust me on this one. Anywho, let's get right into the Japanese learning right here. Alright. We got Biu, and that is obviously Ba Bi, which is this horseshoe shape with the apostrophes right here. Then Yo, it's a conjunction.
Byo.
Yo. Alright. Boom. Easy money. Then we got the yo part. Ooh. Surprised they let us slide with that tracing. But anyways. We got bu. Obviously, it's another conjunction term. I'm pretty sure all these are probably going to be sort of conjunctions. So, yeah, it'll be good familiarization for us. So let's... Bu.
Byo. Byo. Byo.
Oh my god. Window is off. Window capture. Okay. At least I had slowly but surely getting better at this. I realized that was not capturing the screen a little bit earlier than I have previously. So that's good. Progress makes perfect. Alright, let's get the U part done. Oh. Alright. Easy money. We got Bya.
300 yen.
300 yen.
300
300
yen.
yen. Nice. We got Bya. Obviously, B with the Ya makes Bya. Let's get right down to the tracing. Okay. And the Ya part. Oof. Oof. Easy money. Okay. Go to my docs real quick. Okay. Good deal. Alright, let's be we got Gyo. Gyoza.
Gyoza.
Gyoza. Okay, so this is like how it sounds. I guess this is just like two different variations of saying it. Anywho. We got Gyo. We got the Gi first. Can't forget the Gi. Gi Joe. Alright, and we got the Yo part. Nice. Surprisingly let us slide there, but shit is what it is. We got Gyu.
Gyu. Gyu.
Gyu. Gyunyo.
牛乳。
Gyunyo.
牛乳。
Gyunyo is cow's milk. Nice. We got the Gi done. Now we got the U. Perfect tracing skills are perfect. Nice. Very nice, very nice. Boom. Nice. Alright. Let's do some studying. This is Shi. Sha is going to be Shi plus Ya. Gyo. Be. Bo is going to be this one. Bu is going to be this one. You got Zu right here. Yu. Kyo is going to be this one. We got Gi, and that's that. Bo. Oh, Po. Okay, okay. Zet is going to be this one. She is going to, or no, G is right there. We got Hugh. It's going to be right here. Ba. It's going to be this one right here. Q is going to be, here we go. Chu. Chu. Nice, okay. Nyo. De. Okay. Pyo. It's going to be this one right here. Gyo. Gya. Actually, Gya. Alright, we've got Sho. This one right here is Hyo. Got Nyo. New, rather. New. We've got Ryo. Pi. Ryu. I even said it too, that's crazy. Ka. Zu. We've got Ra. Nice. D/G is going to be right here. E right here. Hya is going to be right here. Pu is right here. Gyu right there. Bia right here. Alright, then we got Go. Shu that is she plus you right here. Su is going to be right here. Bu right there. And 2 out of 40 missed. That's not bad at all. We'll take those numbers. Seeing that slow, steady improvement we love to see. We got Ryu right here. Then we got Po. Okay. Po. Gotta remember that degree sign means Po. Alright, now for the main event, let's see what we get out of here. Common poll, unfortunately. But, we'll study some more so we can rip another one maybe. Let me take first sips of coffee of the day right here. You. Obviously, that's me plus you. Mu. Okay. And we got you, obviously. Nice, good money. We got Mia. Mia. And then we got Ya. Pyo.
表
P plus yo.
発表
Hapyo. That was actually one of our best traces ever, maybe. That was actually sick. We got the yo part. Cut the tail off a little bit, but it is what it is. We got pyu in hiragana.
ピュ
Pyu. We got you. Okay, easy money, easy money. We got pia,
ぴゃ
pia. Then we got rapyakuen,
600円
ropyakuen, which is 600 yen. Nice, good deal. Start off with the pie. Nice. We got the ya, of course. Can't forget that ya. Okay. Alright, now it's time for the study. Only 18 this time. That's pi. Or that's pa. Okay, nice. We got pyo. Alright, this right here is A. Got za. Where's za? Za is right there. Nice. We got do. Right there. Zo, that's going to be, I want to say this one, not certain, but at the same time, screw it. Oh, nice. Easy money. This is re. Nice. Got kya, that's going to be ki plus ya. Right there. Easy bread. Pya, that's going to be P plus ya. Oof. And I clicked the pew. That's crazy. We got pe. That is right there. Is the degree symbol. We got cho. That is going to be chi plus yo. Right there. Mu. That is right here. Mia. This right here is B. We've got Pew. Ria. Nice. Riyad Mahrez. We got Cha. It's going to be Chi plus Ya. Right there. Ria. Nia. Psych. Nice. Alright. Missing 1 out of 18. That's not bad. We'll take that. We got Pia right here. Okay. Nice. Easy little level up. We'll evolve soon at level 16. Or 15. I was honestly joking. I didn't even read this little subtext right here, but yeah, I don't know. Wonder what'll happen when we evolve. Let's roll the dice, see what pack we get. Oh, it's a rare pull right there. Doesn't have too crazy high value on the marketplace, but you know, we'll add it to the collection nonetheless. And then we've got the final 4 terms of hiragana to learn right here, it seems. So let's tap in. And yeah, we got Ju. That is she plus squirt marks makes Z. I don't even know. Ju. That is, I assume this is G, right? That's G. Okay, that's what I was trying to say. G, and then that's U. So ju,
10
ju. Nice. All right, let's trace. Oh. Nah, we got to redo that. That was... Oh, it won't let us. Okay. All right, then we got the U part. Can't forget the U part. This is oh so important, and we messed that one up. Nice. Oh, cool. All right, let's hit the U. There we go. We got jo. That is G plus yo. Makes
じょじょ
jo. All right, let's get the tracing done right here. And then we got yo. Ooh, a little bit short there. Nice. All right, we got ja. G plus ya makes
じゃじゃ
ja. Put that on ja right here. Nice. All right, and we got the ya part. Wow, we're being really strict with these tracing here. There we go. Nice. All right, and then moving on, we got myo, which is me plus yo makes
みょ
myo. All right. Oh, I was chalked the moment I started drawing squigglies. Then we got the me done. Now we got the yo. Perfect. Nice. All right, now it's study. They're only giving us 4 turns of study, so we're going to have to hit a quick 40 piece after this, but let's get through this. Jo is G plus yo. There we go. Myo is this one. Alrighty. Ja. Got ju. Nice. Alright. Free pack. Let's see what we get. Another common pull. Nothing crazy. Alright. Let's do focused review. Anything in the schedule. 40 terms. Shoe. Nice. That one is meh. Nice. Typically is ho, but with the squirt marks there, that would make it bow. We've got bi. So right here is ya. We've got gia. No, gyo. Gyo. Nice. Got yo. Got ze. This one right here is gonna be pyo. Pia. Nice. Trying to do it without looking at the options. That is E. Nice. Ju. That is she, which the squirt marks make it G. And then U is right here. We've got Ma is the one that looks like a... Wow. Fumble of the century. I should be getting that one. That one's on me. We got she right there. Got gu right there. Got ja. Nice. This is pa. Do. I think that's this one. Nice. Ryu. Tsu. Zu. Pyo. Fu. Whoa. Oh, whoa. This one's Myo. Do slash Zu. That is going to be this one right here. Ga is going to be this. Cho is going to be Chi plus Yo. Got Q is Ki plus U. Ro is this one. Oh, gotta be better. Terrible. Alright, we got pa, po, pa, po, po. Okay. Nyo, no is ni plus yo, which is not that one. It's actually this one. We've got za right there. Na is this one right here. We've got pew, poo, pew. Nice. Sha, sha. Ki. Hya. Su. So. Nya. Alright, missing 2 out of all 40. That is really not bad. We'll take those odds. We like those numbers over here. So we've got ro. That is going to be... I want to say this one. I think it's this one. Okay. The ma is right there. Okay. Alright. Pretty good. Not too shabby at all. Let's tap the gotcha machine and see what pull we can get. Oh shit. It's a mythic right there. That is crazy. Case hardened. Stat track as well. Very nice. It's gonna go right into the collection. Alright. So after ready for the next schedule. What's that? Amazing, you've studied every term in the schedule or suggested schedules for you to continue learning, which are listed down below. Basics expressions. Okay. And I'm not sure what we're doing here. We're going a little bit off-roading, but you know, life's an adventure. Submit 10 words into the cat. I don't know if I have 10 words in me. Alright, so that's probably going to do it for this portion. I'm going to switch over into some listening practice.
皆さんこんにちは。この動画を撮った日は12月31日です。今、私たちは車であるお寺に向かっています。お寺に着き
The
ま
area
した。
looks so dead. With all these like barren trees and stuff.
今からお寺の方たちと山を登ります。昔、さっきのお寺はこの山の先にあったそうで、そこには今はお堂があり
Damn,
ま
they were
す。
really going on a hike, going off the beaten trail.
お堂と
Literally.
いうのはお寺の
That is goal. This one right here is that's not. I'm blinking right now. Tough.
建物のことで
Let's
す。
see here. Let's hear
お
what
堂
she says.
というのはお寺のお堂というのはお寺の建物のことです。
I don't know.
で
I
も
don't even know what I'm doing right
今
now.
から行くお堂は建物ではなく岩そのものです。しかもその岩はすごく高いところにあります。どうやって作ったのかなって思う不思議な場所です。
It's like something out of like a video game.
深草観音という名前です。
What'd she say this was? Oh,
その場所は深草観音
Fukasa Kasano. I think.
草が深い草 深いというと、草がたくさん生えているという意味です。
Kachikafu. Kari? Is that what she said?
と、草がたくさん生えているという意味です。草がたくさん生えているという意味です。そして観音様というのは、そして観音様というのは、苦しんでいる人を助けてくれ
Is
る
that Bodhisattva? I'm not sure what that means. Bodhisattva. Buddhist who strives to become enlightened and free from others from suffering. It's a pretty noble cause. It's actually really cool. Bodhisattvas. There's something new every day.
仏様です。黄色いテープに危険と書いてあります。危険というのは危ないという意味。
Technical
助けてくれ
difficulties?
る仏様です。
There we go. It's like a little bit like, whoa, what's going on here?
黄色いテープに危険と書いてあります。
Must just be something with the
危険
video
と
then.
いうのは、ピンクのテープが見えますか？
Yes, I can see the pink tape.
ピンクのテープは、ここ
ピンク
が道で
のテープは
すという目印。ピンクのテープは、ここが道ですという目印です。目印は目に
Meji. What'd she say?
目印は目に印、サインと書きます。
Meshi or Meji Roshi. Meji Roshi?
サインと書きます。
Is that what it is? Meji Roshi. Signpost stamp. Did I get that right?
目で見てわかるようにつけるものです。
Sign. Ah, okay.
はい、深草観音に着きました。石段を登ります。その先に
This temple has some aura to it, I'm not gonna lie. It's like a Zelda dungeon to get up there.
はしご
Gotta
の
climb the
上が
ladder, gotta do all this
お
stuff.
堂になってい
It's
ま
crazy.
す。あのはしごは今使えません。
Ladder's not usable? I don't know. You should go over there and try.
でも横の石の階段から行けます。そっちを通ってお堂に行きましょう。
Very steep.
あそこがその階段です。危ないので鎖があります。 その鎖につかまって登ったり降りたりします。
It really is like a
結
video
構
game
怖い
dungeon.
階段でした。下の息子は下の息子はそれ以上登りませんでした。息子は高いところが苦手です。
Yeah, I used to not be good with heights either, but over time you
鎖の
become
階段
comfortable
の
with
先
it.
も結構怖かったです。でもここまで怖いのを我慢すれば入り口はもうすぐそこです。中に入りましょう。
Oh,
この
very
木の
cool.
扉の向こうに観音様が3体あるんだそうです。ご本尊は最初に見た
I don't know what that is. Not familiar with some of these terms. Obviously, that's ho. Ho. Something and
お寺にあります。
definitely gotta keep practicing the
ご本尊
hiraganas.
というのはそのお寺で一番大切な仏像のことです。このノートには来た人が何かを書いていきます。名前とかが多いですね。
Oh, they got a little death note. It's mostly
この
names.
お正
Or
月のポ
reverse
スタ
death
ー
note, I
と
guess.
このお餅を今日持ってきたんだそうです。このお正月の準備のために毎年12月31日にここに来るんだそうです。昔この辺の高さまで海だった
The water
水
used
が
to
あっ
be
た
this high around
とい
here.
う言い伝えがある
That's
そうです。
insane. It's craziness.
下から見えたはしごはこれです。こんなすごい場所によくお堂が作れたなって思います。
It's a
人が
very,
小
very
さいですね。
aesthetic place.
かなり高く感じます。
Very scenic. A good place to have a tote.
では出ましょう。これは岩松という植
Iwamatsu?
物だそうです。
Is that what she said?
盆栽で
Iwamatsu?
人気があるんだそうです。
It's popular for bonsai. Ah, the more you know.
あそこに仏様があります。言い伝えではあそこまで水があった
I wonder how
そ
the
う
water
で
used to be that high. If there's
す。
still
だから
like
あそこ
trees that
で
are growing.
仏様が掘れたというわけです。
Unless they're talking about like way back in the day.
夫は普通に歩いてるんですが帰り道は下りなので余計怖かったです。
It's quite the adventure, it seems.
この先の階段は後ろ向きで降りました。
Oh, look at how rusty that chain is.
後ろ向き
Definitely a
という
good call to bring the
のは
gloves.
背中の方向に進むことです。
What'd she say this is?
降りました。後ろ向きというのは背中の方向に進むことです。
Can't believe I forgot what this is. This first little letter here. We got she, ro, muma.
急な階段進
I don't
も
know. It's not my day today.
おりました。
Seems I'm off the ball a little bit, but you gotta perform even on your worst days.
降りた後、今度ははしごの先に行きました。頭が良くなる神様がいるんだそうです。
There's a god who is said to help improve your intelligence.
はしごに
Nice.
黄色いテープが巻いてあります。
See, in America, you'd still have people running up that,
登ってはいけ
despite
な
what
い
it says.
という意味です。怖い？怖くない？
Looks like there's a beautiful
みんなが
opening
止まっ
up
ている
there.
ので怖いのかと思って聞いてしまいました。単に到着したということでした。こちらが頭が良くなる神様だそうで
Plus
す。
5 intellect. Nice.
しっかりお祈りします。せっかくなのでさらに奥まで行ってみました。行き止まりでした。行き止まりというのはその先でした。行き止まり
Ikidomari.
というの
Ikidomari. Ikidomari. Hey, that's a new word right there. Nice. Ikimasu, ikimadori. Ikimari. Ikimasu.
はその先道がないことです。戻ります。最後にもう一度ご挨拶します。反対側はこんな感じの
Wow.
風景です。
Great place to like have a picnic and just admire the scenery, you know?
では
Nah, probably
も
not.
と来
It's
た
probably
道を
too heavily
戻ります。
populated of an area to have like a picnic or something, but the view is amazing.
右側は落ちたら怖そうな感じになっていま
It does
す。
look rather dangerous if you fell.
左手側には仏様でしょうか。いくつも石像、石の像がありますね。今はこのはしごは使えません。でも2023年の夏に来た時には
I wonder how sketchy it looked when
この
the
黄
ladder
色い
was
テー
up
プはありません
and
で
like
した。
operational.
その時の動画をちょっと見てみてく
I
だ
don't
さい
have。to wonder. She got us covered. Whoa.
友人がはしごを登っています。
How green everything is, man.
見ているだけで怖かったです。ゾッとしました。皆さんはどうですか？
Oh, yeah, I'm
高い
good
と
with
ころは
heights.
大丈夫ですか？
Used to not be, but you know, get over your fears as you grow up.
今上について中に入りましたね。
Yo, what's good? Appreciate it, my friend. How's it going?
では山を降ります。
Now they're
この
going
場所
down
に
the
ついて
mountain.
説明した看板がありました。ご本尊はなんと5.4
What
セ
are
ン
we
チ
up
だそう
to?
です。
Yeah, so this is just pretty much a learning stream.
33 年
So
に
yeah,
一
we're
度
just
しか
learning Japanese right now. We have a language focus. And then you play any game, like video games, or like what you talking about? If video games, yeah, but like that's on it's on a different channel, different sort of deal. What you play? Alright, I'm gonna let this play.
見られないんだそうです。帰り
Play
道
COD?
に
Nah, that's unfortunately like the one shooter game I don't play. I play let's see, I play Siege, Valorant.
子供が欲しい人が
Really messed with Overwatch back in the day. Honestly, Overwatch isn't bad right now. Rivals, yeah, I play a lot of stuff. What about you?
この辺
Other
で
than COD,
あそ
you
こ
play
の
anything?
観音様に向かって硬貨、つまりコインを投げるんだそうです。
You do some cool art stuff. Oh, nice. Sure, yeah, you can like drop like a handle or something. So I do have IG, but I'm not really on it too much. I need to be definitely tap in more to that kind of
あの
stuff. So if you want to drop like your handle or something, I could save it and check it out for sure.
でもみんな入らないけど子供を授かっているということでした。ここを案内してくれた友人もここでお願いしてお子さんを授かったんだそうです。授かるというのは神様や仏様などから何かをもらうことを言います。お金では買えないようなものです。
Save it in my notepad to check out for later.
さらに少し下ったところ
Yeah, can
に
you follow me? So
何かありました。
like I said, I'm not really on it a whole lot, so I'll check out your page
仏
and
様の
yeah,
石像、
definitely like it up and you know try and help your engagement as much as I can.
さっき
What kind
の
of art do you do?
仏様の石像があった場所です。大きい岩ですね。仏様というのは仏教で悟りを開いた人の
Oh,
ことで
new
す。
term potentially about to be learned. We got Hotoke Hotokechima? I don't know if that's right. Let's see.
仏
Digital
様
art. You got Discord? No, I actually need to set up a Discord for this because I know it's a good way to like kind of set up a community and stuff. So I actually might look into starting a Discord maybe later tonight. Try and have it ready by tomorrow in case you know anyone's interested in signing up and you know hanging out. All right, bet. Get that. Cool deal. Alright, yeah. I'll for sure try and set up like some sort of Discord account for this and everything, and yeah, we can have a nice little community.
悟りを開いた人のことです。
Let's see what she just said.
仏様というのは仏様というのは
Hodoke-sama? Is that?
悟
No.
りを開いた人のことです。
If only there was a way like YouTube would let you copy and paste text in a caption and then like, you know, so I could just copy that, go look it up, see if I'm right or, you know, if my if my Japanese skills are still failing me.
でも日常の言葉で仏様
Hotoke-sama. Hotoke-sama. Okay. Nice. It's interesting they have different meanings across the different variations.
またカタカナで仏と書くと違う意味があります。まず日常会話で仏様という場合には
Hotoke-sama refers to a revered being in Buddhism, and this includes Buddhist statues or altars. Ah, very cool.
仏教におけるありがたい
It's interesting
存
how
在、
there's Buddhist influence in Asian countries, but I guess that makes sense.
それが仏様です。なのでさっき見た仏像とか仏壇も仏様と呼んだりします。
So the statues we saw earlier, as she's saying right here, referred to as Hotoke-sama. Nice. New vocab term
死
just
ぬことや
acquired.
亡くなることを仏になるという言い方をしたりもします。
Also, when we refer to death or passing, it's sometimes said to become Hotoke-sama. Passing away.
死んだら仏様になるということ
Oh,
です。
so essentially it's this idea that becoming enlightened after you die.
これと同じような意
Pretty
味で
radical.
カタカナで仏と書くと死体とか殺された人、
Kind of some dark tones are taken during this listening practice.
これは警察の言葉です。
Police terminology
なの
notes.
でドラマとか小説で目にするかもしれません。
Alright, that's probably going to do the language portion of this stream. So let's switch gears real quick into the more technical stuff. So we're going to do some good old macaroni and cheese right here. Where were we? Limits and continuity. So we'll do this for about, let's say 20-25 minutes maybe, and then we'll watch a little bit of this video. I like to kind of I like to set a nice pace between like technical like skills learning and like just stuff that I think is pretty interesting. So yeah, let's get into math right here. Where the heck are we? Up next for you. Okay. Connecting limits and graphical behavior. Is that... I think this is where I'm at. Yeah. Alright. Watch this video. Connecting limits.
So we have the graph of
Good old
y is
Sal
equal
from
to
Khan
g of x
Academy.
right over here. And I want to think
Freaking
about what
goat,
is the
man.
limit as x approaches 5 of g of x. Well, we've done this multiple times. Let's think about
We're
what
stacking
g
up
of
these
x
energy
approaches as
points,
x
man.
approaches 5 from the left. G of
Craziness.
x is approaching negative 6. As x approaches 5 from the right, g of x looks like it's approaching negative 6. So a reasonable estimate based on looking at this graph is that as x approaches 5, g of x is approaching negative 6. And it's worth noting that that's not what g of 5 is. G of 5 is a different value. But the whole point of this video is to appreciate all that a limit does. A limit only describes the behavior of a function as it approaches a point. It doesn't tell us exactly what's happening at that point, what
More
g of
energy
5
points.
is.
Let's
And it doesn't
freaking
tell
go.
us much about the rest of the function, about the rest of the graph. For example, I could construct many different functions for which the limit as x approaches 5 is equal to negative 6, and they would look very different from g of x. For example, I could say the limit of f of x as x approaches 5 is equal to negative 6, and I can construct an f of x that does this that looks very different than g of x. And in fact, if you're up for it, pause this video and see if you could do the same, if you have some graph paper or even just sketch it.
And as x approaches 5 is 6. Negative 6, rather. Yeah, that makes sense.
Well, the key thing is that the behavior of the function as x approaches 5 from both sides, from the left and the right, it has to be approaching negative 6. So, for example, a function that looks like this. So let me draw f of x. An f of x that looks like this and is even defined right over there, and then does something like this, that would work.
It's a weird little graph, I'm not going to lie.
From the left, we're approaching negative 6. As we approach from the right, we are approaching negative 6. You could have a function like this. Let's say the limit, let's call it h of x, as x approaches 5 is equal to negative 6. You could have a function like this. Maybe it's defined up to there, then you have a circle there, and then it keeps going. Maybe it's not defined at all for any of these values, and then maybe down here it is defined for all x values greater than or equal to 4, and it just goes right through negative 6. So notice, all of these functions as x approaches 5, they all have the limit defined, and it's equal to negative 6, but these functions all look very, very, very different. Now, another thing to appreciate is,
You're saying
for
that they
given
go through the
functions,
same point?
delete these. Oftentimes, we're asked to find the limits as x approaches some type of an interesting value. So, for example, x approaches 5. 5 is interesting right over here because we have this point discontinuity. But you could take the limit on an infinite number of points for this function right over here. You could say the limit of g of x
500 energy
as
points?
x
Yo,
approaches,
that's
not x equals, as
it's
x
big bucks right there.
approaches 1. What would that be? Pause the video and try to figure it out.
Limit of g of x as x approaches 1. As we reach 1, where's 1? Right here. Like negative 5.2.
Let's see. As x approaches 1 from the left-hand side, it looks like we are approaching this value here. And as x approaches 1 from the right-hand side, it looks like we are approaching that value there. So that would be equal to g of 1. That is equal to g of 1 based on, that would be a reasonable, that's a reasonable conclusion to make looking at this graph. And if we were to estimate that, g of 1 looks like it's approximately negative 5.1 or 5.2.
Nice.
Negative
Hey, we got it right.
5.1. We could find the limit of g of x as x approaches pi. So pi is right around there. As x approaches pi from the left, we're approaching that value, which just looks actually pretty close to the one we just thought about. And as we approach from the right, we're approaching that value. And once again, in this case, this is going to be equal to g of pi. We don't have any interesting discontinuities there or anything like that.
It's interesting how the concepts stack.
You can
I think
construct
that's the purpose
many
of
different
this video is saying
that
as
would
well.
have the same limit at a point. And for a given function, you can take the limit at many different points. In fact, an infinite number of different points. And it's important to point that out, no pun intended, because oftentimes we get used to
see what
seeing
you did
limits
there,
only
homie.
at points where something strange seems to be happening.
Nice. Good deal. All right. Next exercise. All right, let's see if we got what it takes to get a hundo here. Limit of g of x is equal to 6. Or no, limit of g of x as x approaches negative 2. See negative 2 right here. The limit would be... See, this is why I need to hold myself more accountable and do daily practice, because after a couple of days of not doing it, you kind of forget what you learn, and everything kind of builds off one another in really anything you do. So limit of g of x as x approaches negative 2 from the right, that's going to be, which of these expressions agree with the graph? As x approaches 0 from the right, from the positive direction, actually. approaches 0. Well, that would be 0. That would not be 6. So that doesn't... Oh, wait. Doesn't exist. That one doesn't work. I don't think none of the above is the answer. As x approaches -2 from the right, we got... So this one would be the only correct one. As x approaches -2 from the left. It would have to be that one. Incorrect. Oof. Tough. Okay. Try again. None of the above? No. Okay. So it's this one? Is that if we're just -2 from the right? Or from the negative direction? Oh, okay. So I just got my signs mixed up. That's all that happened. On to the next one. As x approaches -2 or -3 from the positive direction, it's equal to -2. As x approaches -3 from the positive direction, it's equal to -2, so it's not that one. None? I don't think it'd be any. Nice, let's go. Redeemed ourselves. Consider the graph of function h as x approaches -4. The limit is -2. Yeah, I think that'd be right. Why not? Got as x approaches 0 from the positive direction, should be 2. Okay. As x approaches 4 from the negative direction, positive 4, there's 2. That might be right as well. We'll have to see. Almost there. Is it not this one? Ah, it's not the first one. Okay. As x approaches -4, right here, from the positive direction, should be -2. Now, why is this not the case? Can't believe I'm really getting stumped up on this part. My skills have deteriorated fast. X approaches -4 from the positive direction. I don't understand. Okay. I guess if there's a disconnect, maybe? As x approaches 1 from the positive direction, the limit should be 1. Okay, so that's not that. Not that. As x approaches 1 from the positive direction, it needs to be the value needs to be 0. That one. Nice, let's go. That was actually clutch. Keep on practicing. Oh yeah, we need all the practice we can get. Can we reattempt this? Alright. Let's see if we can reattempt. As x approaches -1 from the negative direction is equal to 6. It's not equal to 6. So it's not that one. As x approaches 4 is equal to 5. And that is assuming both sides are equal as x approaches 4. Okay, so it's not that one. As x approaches 6, the limit is -1. As x approaches 6, the limit is not -1. So none of the above. Nice. Alright. we got limit of g of x as x approaches 3 is equal to 5. Okay, so both sides have to add up, or both sides have to align with the limit being 5 here. We've got, let me see here. As x approaches 3, the limit should be 5. Okay, that lines up right there. Should line up there as well. 5. As x approaches 3, the limit's 5. Nice, okay. I was a little bit skeptical. I was like, no way all these are correct, but they are. We've got, okay, limit of g of x as x approaches 1 from the positive direction is equal to -1. Which is 1 from the positive direction. It's equal to -5, so it can't be that. Limit of g of x as x approaches 4 from both sides is 3. As x approaches 4, no, that's -3. Limit of g of x as x approaches -1 from the positive direction is equal to 1. So -1 from the positive direction, that is equal to 1. So, nice. Okay. Alright, let's go for the hundo real quick. Blue hundos only. We've got limit of f of x as x approaches 2 from the negative direction is equal to -1. As x approaches 2 from the negative direction is equal to -1. So it's not this one. As x approaches 2 from the negative direction. No. Wait. Yeah. So it'd have to be this one, or it's none of the above. The x approaches... Oh, wait. Okay. I was looking for -2. So x approaches 2 from the negative direction. Okay. Is equal to -1. That is correct right there. That is not correct. Whoa, what kind of graph is this? So A should be the only one right here. Let's go. Blue hunted. What y'all know about it? We got the secret jingle to boot. How long is this video? Alright, so I think we're going to switch.
So
I'll
we
watch
have
this.
a function f of x
And then
graphed
we'll get
right
into
over here,
something
and then we have
a
a
little
bunch
bit
of
more
statements
interesting.
about the limit of f of x as x approaches different values. And what I want to do is figure out which of these statements are true and which of these are false. So let's look at this first statement. Limit of f of x as x approaches 1 from the positive direction is equal to 0. So is this true or false? So let's look at it. So we're talking about as x approaches 1 from the positive direction. So for values greater than 1. So as x approaches 1 from the positive direction, what is f of x? Well, when x is, let's say, 1.5, f of x is up here. As x gets closer and closer to 1, f of x stays right at 1. So as x approaches 1 from the positive direction, it looks like the limit of f of x as x approaches 1 from the positive direction isn't 0. It looks like it is 1. So this is not true. This would be true if instead of saying from the positive direction, we said from the negative direction. From the negative direction, the function really does look like it is the value of the function really does look like it is approaching 0.
Okay, I see what he's
approaching
talking
1 from
about,
the negative
yeah.
direction,
That's
when
a given,
x
I would
is
assume.
right over here, this is f of x. When x is right over here, this is f of x. When x is right over here, this is f of x. And we see that the value of f of x seems to get closer and closer to 0. So this would only be true if we were approaching from the negative direction. Next question. Limit of f of x as x approaches 0 from the negative direction is the same as limit of f of x as x approaches 0 from the positive direction. Is this statement true? Well, let's look. Our function f of x, as we approach 0 from the negative direction, we use it in a new color, as we approach 0 from the negative direction, so right over here, this is our value of f of x. Then
That
as we
would
get
be
closer,
true.
this is our value of f of
I
x. As we
believe.
get even closer, this is our value of f of x. So it seems from the negative direction, like it is approaching positive 1, from the positive direction, when x is greater than 0, let's try it out. So if, like, say, x is 1/2, this is our f of x. If x is, let's say, 1/4, this is our f of x. If x is just barely larger than 0, this is our f of x. So it also seems to be approaching f of x is equal to 1. So this looks true. They both seem to be approaching the limit of 1. The limit here is 1. So this is absolutely true. Now let's look at this statement. The limit of f of x,
So I guess these are just a bunch of like mock
well, we've already thought
examples
about that.
he's
The limit
doing.
of f of x as x approaches from the negative direction, the limit of f of x as x approaches 0 from the negative direction, we see that we're getting closer and closer to 1. As x gets closer and closer to 0, f of x gets closer and closer to 1. So this is also true. Limit of f of x as x approaches 0 exists. Well, it definitely exists. We've already established that it's equal to 1, so that's true. Now the limit of f of x as x approaches 1 exists. Is that true? Well, we already saw that when we're approaching 1 from the positive direction, the limit seems to be approaching 1. We get when x is 1.5, f of x is 1. When x is a little bit more than 1, it's 1. So it seems like we're getting closer and closer to 1. So let me write that down. The limit of f of x as x approaches 1 from the positive direction is equal to 1. And now what's the limit? The limit of f of x as x approaches 1 from the negative direction. Well, here, this is our f of x. Here, this is our f of x. It seems like our f of x is getting closer and closer to 0 when we approach 1 from values less than 1. So over here, it equals 0.
This does not exist.
So if the limit from the right-hand side is a different value than the limit from the left-hand side, then the limit does not exist. So this is not true. Now finally, the limit of f of x as x approaches 1.5 is equal to 1. So right over here. So everything we've been dealing with so far, we've always looked at points of discontinuity or points where maybe the function isn't quite defined. But here, this is kind of a plain vanilla point. When x is equal to 1.5, that's maybe right over here. This is f of 1.5. That right over there is the point. Well, this is the value f of 1.5. We could say we could see that f of 1.5 is equal to 1. That this right here is the point 1.5, comma 1. And if we approach it from the left-hand side, from values less than it, it's 1. The limit seems to be 1. When we approach from the right-hand side, the limit seems to be 1. So this is a pretty straightforward thing. The graph is continuous right there, and so really if we just substitute at that point, or we just look at the graph, the limit is the value of the function there. You don't have to have a function be undefined in order to find a limit there. So it is indeed the case that the limit of f of x as x approaches 1.5 is equal to 1.
All right, nice, cool deal. Let's go up to lesson 3 real quick. Approximating limits using tables. All right, we'll learn that tomorrow. 2-week streak. Heck yeah. Rocking out. All right, let's go back and we'll watch a more engineering focused video. All right, why are engines becoming non-renewable or non-rebuildable?
Had the opportunity to visit an engine manufacturer.
I need to turn down super speed.
Manufacturing plant in Spain where I got to see something really interesting called bore spray coating, where a cylinder coating is basically directly sprayed onto an aluminum engine block instead of using a traditional cast iron cylinder sleeve or liner. This process apparently reduces engine weight and it improves efficiency and emissions, but it also makes the engine non-rebuildable. In response to this,
yeah, I was gonna say, I wonder if there's any downsides, but as he said, it is non-rebuildable.
Viewers commented how this making engines non-rebuildable is actually planned obsolescence, and how non-rebuildable.
So planned obsolescence. That's like what they do with the iPhones when they, when you notice that your iPhone's becoming old, and like it starts operating slower. I've noticed that personally. That's like basically planned obsolescence. It's kind of like a psychological thing to get you to keep buying the latest thing.
Engines are bad for the environment. And this got me thinking, and then I decided to dig into it, and then based on all of this thinking and digging, I made this video. And in this video, we're gonna do 2 things. Number 1, we're going to list and explain all the different mass production popular engine cylinder coating processes, stuff like Nikasil, Alsil, and so on and so forth. There's a bunch of them. We're going to see how they work, how they're different from each other, why they came into existence, and what kind of benefits and drawbacks they offer. And this will then help us understand whether these coatings really are planned obsolescence disguised as environmental friendliness, or whether there's a different motivation for these coatings. And number two, what we're going to do is that I'm going to use data from scientific research and reports from reputable sources to try and hopefully quantify and measure the environmental impact of non-rebuildable engines. One of the first cylinder coatings to be used in mass
Immediately
production.
off rip on that environmental impact, I'd imagine since they're non-rebuildable that and you're using more parts in totality, since there's nothing salvageable, probably be worse for the environment, I'd have to assume.
Also probably one of the most famous. It's called NiCSiL. NiCSiL stands for nickel silicon carbide, and it's essentially an electroplating process, and so it works just like any other electroplating process. So what we have is a solution or a bath, basically a liquid, which is filled with nickel ions and silicon carbide particles. Silicon carbide is essentially a ceramic which is extremely wear resistant. What we do is that we put our cylinder block in the bath, and then we connect the negative side of a power source to that block, which makes the block our cathode. And then we take a nickel bar, dip it in the solution, and connect the positive side
This is
of our
some
power
scientific
source
ass
to the
shit they're
nickel
doing
bar,
right now.
which makes
That's
it our
crazy.
anode. When we turn
What did
on
you
our
just say?
negative side of a power source to that block, which electroplating process, and so
Nickel
it works
silicon
just like any other
carbide.
electroplating process. So what we have is a solution or a bath, basically a liquid, which is filled with nickel ions and silicon carbide particles. Silicon carbide is essentially a ceramic which is extremely wear resistant. What we do is that we put our cylinder block in the bath, and then we connect the negative side.
So
of
you're
a
essentially
power
trying to
source
attract the
to that block,
particles?
which makes the block our cathode. And then we take a nickel bar, dip it in the solution, and connect the positive side of our power source to the nickel bar, which makes it our anode. When we turn on our power source, electricity of course starts flowing from the anode to the cathode. Nickel ions from the solution, they move toward the cylinder and coat its surface, whereas silicon carbide particles, they get trapped in the nickel layer, creating a very thin, but at the same time very hard and very wear-resistant NiCSiL coating. Okay, so that's how it works, but we have to ask ourselves, why bother with all of this electroplating nonsense when there's really nothing wrong with traditional cast iron sleeves, because they've been used on thousands upon thousands of engines without really any sort of major widespread issue. Well, what's important to understand when it comes to cylinder coatings is that they were never about fixing a problem. They were always about pushing the limits, enabling the engine to do something that it could not do before. In other words, cast iron sleeves, they have some key limitations that NiCSiL, for example, does not. Number one, NiCSiL is anywhere between 0.05 to 0.15 millimeters thick.
It's like some
Whereas
sushi
a
norm.
cast iron sleeve is anywhere between 2
Sushi
to
nutty.
7 millimeters thick. And that means that a cast iron sleeve is essentially a barrier to heat transfer, because cast iron is a lot worse at heat transfer and heat dissipation compared to aluminum. The much thinner NiCSiL coating is better at heat dissipation and heat transfer. And because we have that, we can push our engine into higher combustion pressures and higher combustion temperatures without overheating or straining the engine, and that means
So NiCSiL is
more
actually way more efficient
NiCSiL coatings
in terms of
also
heat
have
transfer
much
than
better
iron
dimensional
traditionally
stability
is.
under any conditions compared to a cast iron liner. And this improved dimensional stability means that we can make giant bore engines and reduced bore spacing. We also, for example, we can make two-stroke cylinders with giant ports. All
Two-stroke
of
cylinder
this
kind of
was
guy.
impossible, and it's
Sheesh.
still impossible with a cast iron sleeve because we compromise the structural integrity of the sleeve. And that's because a cast iron sleeve, it creates strength with bulk. It must have a certain amount of material everywhere to remain stable. The fact that the cast iron sleeve expands and contracts when heating up and cooling down
It's kind
at
of
a
crazy.
different
It
rate
say expands and
compared to
contrasts
a truck
almost like
to
our
remain
lungs.
stable. The fact that the cast iron sleeve
Some deep
expands
shit
and
right there.
contracts when heating up and cooling down at a different rate compared to the surrounding aluminum block, and so it can sink or seize in the block or crack or whatever, this is another aggravating circumstance for the sleeve. Number 3, a Nickel coating is actually much more wear resistant and durable compared to a cast iron sleeve, and that means that it deals better with high loads and extreme piston speeds, and that of course means a higher redline and potential for even more performance. The increased durability and wear resistance also of course means that the engine itself lasts longer with a Nickel coating. Number 4, a Nickel coating offers reduced friction compared to a iron sleeve, and reduced friction of course improves efficiency and performance. And finally, number 5, a Nickel coating is much thinner, there's much less
So
material,
Nickel is
we're
just built
actually
different
saving weight,
essentially. So we're learning
usually
here.
about 5 to 7% per engine block. That's how much weight we're
It's
saving.
lighter,
and
it's more
weight reduction
efficient.
is always a good
It's not
thing,
to
as
like
we know,
about
because
it.
it improves both performance and fuel economy. As you can see, Nickel is better at everything that matters compared to a traditional
Nickel
cast
diff.
iron sleeve. Now, Nickel was actually perfected in the late 60s by Mahle, German company which was working at the time together with NSU, and they were trying to make a Wankel engine apex seals of the rotor last a reasonable amount of time in rotary engine casings, aluminum casings or housings. The first to actually implement Nickel in a piston engine was Porsche. Porsche. That's how you say it. They first used it in their 917 race car, and then later in their 911.
That thing looks sick. I actually have
After
that
this,
in
Nickel started
GTA
spreading
though.
quickly to motorcycles, where it became very popular in two-stroke motorcycles, where it's used successfully to this day. And then in the 90s, we also got it in BMW M52 inline 6, the M60 V8, and in Jaguar's AJ V8 engine. However, it was soon discovered that Nickel had a weakness. It was weak to high sulfur fuel, low quality, high sulfur content fuel. The most common explanation of the problem is that the sulfur in the fuel reacted with moisture to create sulfuric acid, which essentially over time
like
dissolved
sulfuric acid
the
around
Nickel
here.
coating. And without the Nickel coating, aluminum has the wear resistance of a wet biscuit, and so the engine fails.
Hey, don't sleep on the wet biscuit
This was really
for
only a problem
wear
in the
resistance
United
though.
States back at the time, not really so much in Europe, almost in some countries absolutely not a problem, because already in Europe at the time in the 90s we had fuel quality standards which limited the amount of sulfur in the fuel. However, this fuel quality weakness wasn't really what spelled doom for Nickel. What spelled doom for it was that it's a slow, labor-intensive process, and that makes it expensive. And that is the #1 word on the list of words that manufacturers hate. So what manufacturers decided to do
Manufacturers
is try
love to
and
cheap
get
out on products
all the
if
beautiful benefits of Nickel
save them a
without paying
substantial
all
amount of
the
money.
And so they moved some letters around and created Alusil. Alusil is essentially an etching process. You cast the entire engine block with a very high content of silicon, usually around 17%. Once the block is cast, you either chemically or mechanically etch away the aluminum in the cylinder, and so what remains exposed is a layer of silicon, and silicon is a durable and hard-wearing material. Overall, the process is much faster and more cost-effective than the electroplating complexities of Nickel. But still, manufacturers were not happy. They wanted to make it even cheaper. And so what they did is that they came up with another acronym. This one was called Lucasil. And the whole point of Lucasil is to not cast the entire engine block with a high
So you're
content
only
of
putting silicon.
because
You're only putting silicon in the most important parts of the engine. In Lucasil,
we
so
only
it's
need the silicon in the cylinder.
another
right?
way they're cheaping
So
out
what
on stuff.
Lucasil does is that it uses pre-made inserts, which are essentially silicon suspended in some sort of resin. These pre-made inserts
Damn, they got
placed
live
in the
resin.
mold, and then the melted aluminum enters the mold. The high temperature aluminum melts away the resin, and so what remains is a layer of silicon on the surface of the cylinder, the only place where you actually need it. Now manufacturers were finally happy because Lucasil was
It's actually pretty
ultra-fast
smart. I
and
don't even know
dirt
if that's
cheap.
cheaping out.
A most arousing combination of words for any manufacturer. And what one manufacturer likes, so too does another. But what manufacturers do not like is paying license fees to other manufacturers. So what do? Of course, they come up with more acronyms. Our final acronym for today is
Acronyms
called
galore.
Silitech. Now, Silitech
Silitech.
is very similar to Lucasil because You also have a pre-formed
Silly
liner,
tech.
and then you cast the block around
Nice.
that liner. But apparently, it's legally different enough. The liner is of a different composition enough, and maybe the manufacturing is slightly different, so you don't have to pay license fees. In fact, so Mercedes doesn't have to pay license fees because you can sort of think of Silitech as Mercedes's version of Locasil, because Silitech
Okay.
is almost
So each company kind of has their own
exclusively on
thing, but they have to
Mercedes
call it a different name.
all three of these coatings,
For licensing
Alusil,
reasons.
Locasil, and Silitech, they were supposed to offer the benefits of Nicosil while having a much lower cost for manufacturers. In other words, they were supposed to last longer and be more durable than a traditional cast iron liner, just like Nicosil is more durable than a cast iron liner. Unfortunately,
so
in
you're-
practice, Locasil, Alusil, and Silitech, they proved to be less durable. They lasted less
So
than a traditional
naturally,
cast
the cheaper
iron liner.
products are
The
less
issue is
durable.
that
Makes
over
sense.
time,
It's pretty much like
the
that with anything.
exposed silicon particles,
Ooh,
they broke
earthquake.
away, they fell off of the cylinder, they circulated
Gotta stop
through the
bumping my
engine.
desk.
The bores were left exposed. We got bore scoring, loss of compression, high oil consumption, and eventually a failed engine that needs a rebuild. Locasil was sort of the worst one of all. It had the poorest longevity. Fortunately, it was the one with the least widespread use by far. Silitech sort of did okay in naturally aspirated applications, did worse in high temperature direct injection turbocharged applications. Alusil, also a very mixed track record, was absolutely horrible in some cases, sort of okay in others. Overall, we can conclude that Alusil, Silitech, and Locasil,
So we
from
don't want
a
no Alusil,
long-term,
Locasil, or
reliability
Silitech in our
perspective,
engines.
they were
What about
not
Nicosil?
a
Kind of,
success. Interestingly, with the exception of the Chevrolet
focus.
Vega,
Yes.
or is it Viga? Viva Las Vegas.
Chevy Vega.
So it's a Vega. Chevrolet Vega. With the exception of that car, it was pretty much exclusively German manufacturers that used Locasil, Alusil, and Silitech, and more often in their more upmarket, more expensive engines, large V8, V12. Yeah, just saying. Now, despite the sort of reliability failure of these coatings, it is undeniable that a thin coating has many benefits over a thick iron liner. And so manufacturers did not give up. They decided to try to find a new way to avoid cast iron
Looking
liners.
for that
And
one
what they
size
did
fits all.
ultimately and finally is that they gave up on all the etching and the scratching, and they decided to spray the cylinder liner onto
Turn
the
it
block.
up a little
And
bit.
that is the exact process that I got to see when I visited the Horse Valladolid factory in Spain. It is called bore spray coating. Now, there are different kinds of these processes, but they all fall within the same category, within the same sort of family of cylinder coatings, and they can be called thermal spray coatings. All of these processes have in common the fact that we have either one wire or two wires made from whatever metal or combination of metals we want. Usually it's a nickel iron alloy or something similar. You can think of these two wires as essentially welding wires. We pass a ridiculous amount of electricity through these wires. The electricity arcs from one wire to the other, just like a spark plug, but much, much, much more intense. This arc is essentially plasma. It's a superheated gas, a
Sheesh.
high energy state of matter.
We're not talking about
This
that plasma
incredibly
that you
hot
donate either.
gas
That's
then
that
starts
real deal stuff.
melting and atomizing the wire into tiny droplets. When that starts happening, we use another gas, either compressed air or nitrogen, to push, carry, and deposit these droplets of molten metal onto the cylinder. The droplets splatter, instantly transfer heat away, and solidify on the cylinder as a special coating. Now, thermal spray coating requires a massive initial investment in very expensive machinery, but in the long run and at sufficiently high volumes, it's actually more cost
Look at the
effective
size
per
of that
cylinder
thing. Holy
than
cow.
a iron
That's what she
liner.
said.
The
But
added
sheesh.
benefit for manufacturers is that the process is generally very fast, easily scalable, and it's easy to adapt it from one engine configuration to another because the very same machine can do all kinds of different engine blocks with minimal downtime in between. The end result is again, of course, a very thin coating which is supposed to improve heat transfer, reduce friction, and improve durability. To engines which have thermal spray coatings, which will be well known to petrol heads, are the Ford Coyote 5-liter V8 and the
Good old
VR38
Ford
DETT engine
Coyote.
as found in the R35 and Nissan GTR. Of course, there are nowadays many more engines with thermal spray coatings on them, and overall in the last decade or so, thermal spray coatings have demonstrated to overall have a noticeably better long-term reliability track record when compared to Ausil, Silitech, and Locasil.
So
Okay,
thermal
so
spray
now we know
coating is
how
what
it's
you
done.
want on your
We
engine.
know the benefits, and that means it's time to ask the next question, and that is planned obsolescence. Is making engines non-rebuildable through the use of engine coatings planned obsolescence? Before we answer that, something very important that has to be said. Coatings do not necessarily make an engine non-rebuildable. In the case of Nikasil, an engine is rebuildable. There are many businesses around the world which do replating of engines with Nikasil. In the case of Ausil, Locasil, and Silitech, we can say that the engine is non-rebuildable because you would theoretically need to cast the engine again. There are some companies and businesses around the world which rebuild Ausil, Silitech, Locasil engines. Probably an even a lower number of companies that do this rebuild well, because you have to re-sleeve the engine. You cannot recoat it, you cannot replate
Definitely
it.
seems like a whole
You can convert
process.
such an engine to Nikasil, but you cannot make it Ausil again. So the only thing you can do is to either make it Nikasil or put in sleeves. And doing the sleeve way can be tricky. So, hard to rebuild is all we're going to say about Locasil, Silitech, and Ausil. Thermal spray coating, there is nothing stopping, in theory, anyone from taking a worn-out thermal spray coating engine, machining away the old coating, and then reapplying the coating
Simple as that.
again, and have an essentially
as
rebuilt
ABC.
engine. You do the honing, and it's rebuilt. Actually, there is something stopping someone from doing that, and it's the cost. The thermal spray coating machinery and optical verification machinery that's needed for it is so prohibitively expensive that your nearest machine shop has no chance of affording it. So, the engines are not non-rebuildable. It's the machinery that is expensive. So, let us rephrase the question.
The bright side is that if a big brand tries to do that method, then they can foot that upfront cost and still get the
Is
long-term
making
cheapness
engines
and
non-rebuildable through the use of
quality
prohibitively
meet
expensive equipment
best
just
of both
another form
worlds.
of planned
Essentially, that's what I'm
obsolescence?
trying to say.
The answer is no. And it's no because our question contains in it the answer: prohibitively expensive equipment.
Yeah, essentially that restricts it to only the top
To achieve
brands. I
thermal
would
spray
think.
coatings, you have to do a lot of research and development. Then you
Good
have
old
to
R&D.
invest in extremely expensive machinery that applies the coating, and then in extremely expensive machinery to do the optical verification of whether the coating has been applied properly and to have the necessary quality control. Doing this would be probably the stupidest way of achieving planned obsolescence because it's extremely expensive. And planned obsolescence can be achieved in basically free, extremely cheap, very easy, and inconspicuous ways. You take your part, whatever it is, you use a simulation software, you simulate a certain number of thermal cycles. And then you take whatever part you want, water jacket, oil gallery, cylinder, support, structure, doesn't
Always
really
booting
matter.
up the CAD.
And you reduce
Autodesk.
the thickness of that part, or you switch it to a ever lower quality of material until you achieve failure in your simulation at the desired number of thermal cycles. That's it. That's planned obsolescence. It costs you nothing. It's actually saving you money because you're using less or a cheaper material. The deal is that with modern emissions and efficiency standards, manufacturers are using aluminum engine blocks and coatings not because they want to, but because they have to. Modern engines are expected to make maximum power and minimal emissions. That is extremely hard to do, and it leads to pretty much always to very high combustion pressures, very high temperatures, and the engine tends to run very hot. So an open deck aluminum engine block with a very thin cylinder coating is needed for thermal control of such an engine. Without this configuration, the engine would melt down. Now, you might be tempted to say, hey, but the Toyota 2JZ can make 1,000 horsepower reliably without melting down, and that's a cast iron block. Sure, and it's also a very irrelevant example because that's a racing project car somebody built, and
Probably doesn't
to
have
not
the,
melt down,
the
such
consistency
engines
of
and
a
motorsport as
typical
well, they run at 11
car
to 1
engine.
air-fuel ratio, something like that, and that is extremely rich. The extra fuel in the air-fuel mixture vaporizes and it takes away heat temperature from the combustion chamber and prevents knock and engine, failure. A production engine cannot, especially a modern one, cannot afford to ever run at such a high air-fuel ratio because that leads to, number one, horrible emissions, and number two, horrible fuel economy. So modern engines, they have to make a lot of horsepower per liter of displacement while at the same time running lean. And again, as we said, the result is always going to be very high temperatures, and we need to control these temperatures
Yeah, we
somehow.
don't like high
It also
temperatures in our cars.
explains
That's
the Nissan
it's a recipe for
R35, the
disaster.
R38 DETT engine. The Nissan R35 had to make more power than the Nissan R34 while respecting more stringent emission standards. This is why the R35 had to abandon the cast iron RB26 engine block and go for an aluminum coated engine block. Now you may think that the R35 is not a relevant example for anything, right? That's extreme performance, and we're kind of talking about family car engines here. They have much lower ambitions. Well, here's an example. When I was in the Horse Valladolid engine factory in Spain, I had the opportunity to see the HR13 engine, which is a 1.3 liter four-cylinder which makes 170 horsepower in certain markets. When you take the horsepower
Not
per
much of a
liter
car
of that
guy, but
engine,
I assume
it's
that's a
right
lot.
around 130 horsepower per liter, just like the Nissan R35 at 500 horsepower during its, early years. So what was extreme performance a decade ago is what we expect from family car engines today.
Pretty insane. Welcome to the future.
And now the final question. Are non-rebuildable engines bad for the environment? I'm going to answer that question by throwing a lot of numbers at you. These numbers come from multiple sources. If you want to see the sources, they're down in the description. And I decided to focus on just the European Union and only on CO2 emissions to keep it manageable for a single person. Okay, let's see the numbers. In 2023, 10.5 million new cars were registered in the EU. The average European drives 10,900 kilometers per year. The average fuel economy for these new passenger cars is 5.6 liters per 100 kilometers. The average CO2 emissions are 106.4 grams of CO2 per kilometer. Thermal coatings improve engine efficiency by 5% and thus reduce CO2 emissions by 6.5 grams per kilometer. And if every one of our 10.5 million cars gets a thermal spray coated engine, then we are going to reduce our CO2 emissions by 41,669 tons of CO2 per year. Now let's imagine
pretty
that
insane.
our 10.5 million cars are at the end of their lifespan. Each of them has an engine block. The average weight of an engine block in Europe is 30 kilograms. Recycling 1 ton of aluminum produces 0.7 tons of CO2 emissions. So if we recycle all of our 10.5 million engine blocks, we'll produce 220,500 tons of CO2. Now, engine remanufacturing produces 20% less CO2 emissions than aluminum recycling per ton. So if we rebuild all of our engines instead of recycling them, then we will save 44,100 tons of CO2. However,
Okay,
thermal
so
spray
thermal
coating saves
spraying
41,669 tons of
essentially
CO2
just as effective
per
as rebuilding
year.
engines.
And it takes a car a decade or two
Probably,
to
if I had to
reach the
guess,
end
maybe a
of
little
its
bit
service
easier
life,
other than the
which means
upfront
that
cost
overall,
to
thermal spray
spray
coating
coat.
saves much
Yeah.
more CO2 than rebuilding does. even if we take our 5% efficiency gain from thermal spray coating to be over-optimistic, we halve it, we put it to 2.5%, even in that case, thermal spray coating still saves more CO2 than rebuilding. So thermal spray coatings are good for the environment. Well, maybe. Let's be realistic. What I just told you is superficial data analysis at best. It's an educated guess at its most optimistic version, because there is an incredible number of data and an incredible number of variables we're talking about here. And I'm just analyzing a little.
Analyzing essentially in a vacuum,
publicly available.
not in actuality and in practice.
So let me just point out some of the issues. We're comparing rebuilding versus recycling. The reality is, of course, that not all the raw materials for engines come from recycled metals, of course. And this varies across different engines, different parts of the world, different manufacturers. And that's, of course, because the products of recycling simply aren't suitable for certain engine types or manufacturing processes. And recycling itself is also a process of great variation. It produces, stuff of different grades of qualities. And for the recycling, it depends where your energy comes from. Is it renewable, And engines themselves, recycling them can also be tricky and complicated, because you have your coatings, you have your hardenings and the materials, you have weird alloys, you name it. All of that can be very tricky to recycle. And we're just taking into account CO2. There's a bunch of other stuff in both rebuilding and recycling. You have your chemicals, your residues, your other emissions, and any one of those could skew the results in a different direction. And what we're also not taking into account is that when you rebuild an engine, you're reviving something that has the emission standards from 10, 20 years ago. And nowadays,
so you still got to update it
engines can improve a lot in 10 or 20 years.
To current standards, okay.
So what I'm really
So
trying to say is
of
that there is
variables that come into play, as he's saying.
Data here, an incredible amount of variables, and trying to sort of give you this one simple sentence, this is good, this is bad, I don't think that's realistic or scientific or objective. So what I can give you is my subjective personal opinion that I have sort of developed after reading and digging through all of these papers and reports and research. And I personally think, based on the publicly available data, that thermal spray coatings, when applied properly and when they do not shorten the life of the engine like Ausil, Lakasil, and Silatic, they are better for the environment than engine rebuilding, because engine rebuilding cannot hope to offset the amount of CO2 that is saved by the thermal spray coatings, even if we are pessimistic about their efficiency gains. And we also have to be realistic here. The cost of engine rebuilding has risen so much in most developed countries that it simply doesn't make financial sense to do a proper rebuild of a family car engine that is 10 or 20 years old. At that stage, the rebuild of the engine is usually going to cost more than the car itself. Realistically, the only engines that get rebuilt nowadays are industrial, freight, or vintage, special, valuable motorsport, or a combination.
So spray coating is generally just a lot more efficient. Nice.
So, engine cylinder coatings. How they work and what they do, both for your engine and for the environment. I hope you enjoy that. I hope you maybe learned something.
Yeah, we learned a lot.
And as always, thanks a lot for watching. I'll be seeing you soon with more fun.
Shout out to this dude, the GOAT. This dude's a wealth of knowledge. Gotta leave him with a little like-a-roni right there. And then we're gonna... I saw this video, this caught my eye. On the side, how do graphics card work? Exploring CPU architecture. So we're gonna... If I can save to watch later. And yeah, that's probably gonna do it for today. Yeah, thanks for tuning in. It's great talking to y'all, and yeah, hope y'all have a great day, and get out there and learn. All right, see ya.